Section 2, we're doing something very similar, but with one extra step. In fact, we're going to skip, well, no, let's do a couple of these just real fast. Number 1, this is exactly what we were doing before. The first part, exactly the same. Go ahead. And Kenji, here's what we're working on. I think I already put one on your desk. Okay, stay focused. Number 1, 30 and 24. It's just a fraction. Let's go ahead and simplify that. Let's figure out what goes into 30 and 24. Jeremiah, any ideas? What number goes into 30 and 24? 6. So if I do 6 into 30, that leaves me with 5. And 6 into 24 is going to be 4. So that's perfect. He simplified that all the way down. How about the r's? Kenji, I know you just came back in, but we've got r on the top, r to the 4th on the bottom. How would I simplify that? 1 Say it again? 1 minus 4. So r to the 1 minus 4 gets us r to the negative 3, right? Yes. And that means it goes on the bottom. And remember, the other way we could be doing this is saying, well, we had 1 r on the top, 4 on the bottom. We can cancel out 1 and leave 3 on the bottom. We're actually not going to do the next couple ones because it's exactly the same as what we've been doing. So as long as that made sense to everybody, we should be good to go down to number 5. We did, because we don't need to practice that. I put those on there in case we had finished the other one completely yesterday, and that was just a little reminder of what we had done yesterday. But since we were finishing yesterday's work today, we're good. So don't worry about 2, 3, and 4. Look at number 5. Does everybody see the minus sign? This minus sign causes us a problem. Okay, everybody. I'm going to show you a quick note. Let's do 10 divided by 6. How does 10 divided by 6 simplify? What goes into 10 and 6? A 2. Is everybody good with this reducing? 10 goes into 2, or 2 goes into 10 5 times. 2 goes into 6 3 times. This reduces to 5 over 3. Correct? So why can't I do this then? 6 plus 4 over 6. Cross the 6's out. Well, that's equal to 4 then. Does everybody see how that's obviously not the right answer? You cannot cancel out stuff that is added or subtracted to something else. Does that make sense? This adding or subtracting would have to happen before I can do any simplifying. Does that, again, you've got to get that down or else you're going to be making tons of mistakes today.
So you just add the top and then you find whatever goes into both of them.
Yeah, if you're actually going to cancel it out, it needs to be no adding or subtracting on the top or the bottom between the pieces that you're...
It's a normal fraction.
Yep, needs to be like a normal fraction. We can do, like that 10 is 5 times 2, and the 6 is 3 times 2. Does everybody see that what we actually did here was we canceled out the 2's? We divided both of them top and bottom by 2. This is fine. Canceling out stuff that's multiplied together is what we normally do. That works perfectly. That's what we're supposed to do. You cannot cancel out stuff that is added or subtracted. This does not work. So right here, that gives us a problem on number 5. I can't cancel out anything on the top as long as this minus sign is right there. The other issue is I don't know what 9r minus 24 is. I can't combine those because they're not like terms.
That's negative 15.
It would be if that r wasn't there.
You just put the r with the 15.
So, what we're going to do instead, leave it off. What we're going to do instead is look at these and see if we can factor them. Class, what goes into 9 and 24? 3.
Bro, I'm just.
So we can take that 3 out. 9 divided by 3 is 3r. 24 divided by 3 is 8. If you can't do that in your head, feel free to use a calculator. You can do 24 divided by 3, get 8. What this does for us, okay, everybody's full attention, because this is the whole point of what we're going over right now. This locks the minus sign inside that set of parentheses. This is all one piece now. Okay, I cannot do anything with the inside of that. I'm going to leave it all as it is. I cannot cancel out parts of it. But I can cancel out the number that's multiplied out in front. Does that make sense?
So you just divide 3 by 30?
Yep, 3 and 30 are both divisible by 3. 3 goes into both of those. I can cancel that out. 3 goes into 30 10 times. This reduces to 3r minus 8 over 10. Now, I'm going to periodically ask you things today that don't work. Can I cancel the 8 and the 10 out? No, because that 8 is a part of a subtraction. Anything that's attached to a addition or subtraction cannot be canceled out. That is the whole point. So you guys are 3 days ahead of Math 3 right now. This is what they're going over on Friday and then next week. This part, what I just showed you, is the whole point, pretty much. It's like one of the main pieces of Unit 4 for Math 3, is that idea that you can't cancel out stuff that's not multiplied together. If it's added or subtracted, we cannot touch it unless we can factor it out. So, let's try number 6. Everybody sees this negative down here. That's our key, that's our clue that we can't cancel stuff out until we factor. So, what do you see on the bottom here that these two have in common? What can you factor out?
These have 2.
Let me say that again. We've got 12n squared and 12n. What do they have in common? What we're doing right now is greatest common factors.
12.
They both have a 12. Let's take that out.
Bro, I got it. You're not guessing.
Is there anything else that they have in common? So we could have done 4, but we decided to do the 12 because that's the bigger number. We want to do, so if you pull out a 4, the goal would be to notice that you can also pull out a 3. Does that make sense? So we want the 12. That's as big as I can get for this one. But if you see something else that they have in common. The end. This one has 2, this one has 1. So we're not actually going to combine them. We're going to say that I can take one n out of both. Again, this is tying back into what we've done previously and what you guys did last year with greatest common factor. If I take 12n out, Caden's right that we had n squared here. That means there's still one n that I didn't do anything with. But I took the entire thing out of the other one. 12n, it's going to be a minus 1. Does that make sense? If I multiply that back in, 12n times n is 12n squared. 12n times negative 1 is negative 12n. I get the exact same thing back. All over 54n cubed. This n minus 1, this is one piece, one block. I can't cancel out a part of it unless I can cancel out the entire thing. So it's going to stay together. But I can cancel out stuff with the 54 and 12. What's the biggest number that goes into 12 and 54? 3. 5 minutes. So I think you could go a little bit bigger.
1.5.
Yes, but we're aiming for whole numbers. Getting closer though. Class, are they both even numbers? So 2 is going to go in?
6.
So let's take the 3, right, the 3 that David said, and the 2, gives us 6. Christian, focus. Gives us 6. That's the biggest number that we can take out of both of those. 6 goes into 54 9 times. 6 goes into 12 2 times. Is everybody clear that that doesn't factor anymore, right? 9 or simplify anymore. 9 and 2 don't have anything in common. If you did just the 3 or just the 2, you would have been able to simplify a second time. So we've got 9 on the top, 2 on the bottom. The ends. We can also cancel out one of the ends here and 2 of the ends up here. Or sorry, one end on the bottom, one end on the top, which leaves us with 2 on the top. Is everybody following along? Cancel out one of the ends, leaving us with 2 on the top. So now the top is 9n squared over 2 times n minus 1. Can I cancel out these ends? No, because this one's a part of a subtraction. Okay, I want you guys to try 7 and 8, but not yet. Okay?
Wouldn't the n minus 1 be a subtraction and a multiplication since it's parentheses?
Right, but it's the whole thing that's multiplied by 2. And so I'm going to show you what we can do with that right now. But this is my answer for this problem. Okay, everybody. So, CART students, in particular, 7 and 8, I want you to try on your own. But before you go, I need to show you one last thing. This is what we're building up to. Everybody else, your focus, please. Everybody's full attention here. Number 10. Number 10. Remember how we were doing all that factoring the last couple units? N squared minus 49 is the difference of squares. That's n minus 7 times n plus 7. That's the top factored. And then here, what multiplies to 70 and adds up to 17? Well, 7 and 10. We now have 2 blocks on the top, 2 pieces on the top, and 2 pieces on the bottom. Do you guys see one that's the same on the top and the bottom? Almost. Do you see what's on the same on the top and bottom? So literally, if you answer my question, I'll let you go.
Yeah, it's positive and negative. They're positive and positive.
So specifically, n plus 7 and n plus 7 are exactly the same.
So those cancel out, right?
You can cancel out the whole thing. And there's your answer. Cart, you can go. Try to finish up through number 10. So 6, what is that, 7, 8, and 9. All right, the rest of you, take 5 minutes to do those 3 problems. The ones that I told them they had to do. I want you to do 7, 8, and 9. Do 7, 8, and 9 now. We'll go over the answers in just a moment.